Hello and welcome to this video on vehicle concepts and chassis, where we will look at small electric vehicles to foster urban mobility solutions. In this video, we will give you an introduction into the world of vehicle conception and give you a step-by-step example of how to design your own small electric vehicle for urban use. Let's start straight away with a look at the agenda. In the general introduction, we will give you some information on the aim and purposes of this video and also who we would like to address. In How to Design a Vehicle Concept Part A, we give you a general overview on how to design a vehicle concept and try to understand design principles and fundamentals, but also technical considerations and production issues. In the subchapter of Design Guidelines, we look more closely on guidelines regarding materials, mechanics, assemblies, and adaptation. In Design Requirements, we take a look at the sources of requirements and how to take them into account. In How to Design a Vehicle Concept Part B, we go into detail on the design of a vehicle concept and chassis by using the example of a battery electrified three-wheeler, our so-called e-tuk-tuk. Deriving domains for vehicle conception will deal with the split of the vehicle in logic domains. Design of the domains will be a detailed domain-by-domain and step-by-step guide on how to design, build, and assemble an electrified tuk-tuk. In the final check of the vehicle concept, we will explain what is needed in order to check the vehicle, and in the very end, we will give you a very brief summary of the topics that we have touched. If you want to skip a chapter, you can use the timestamps given in this video. So let's get started and have a look at the subjects to come. Let's start with the general introduction. The general introduction shall give you an overview on the aim and purposes of this video and who we would like to address. So the overall aim of this course is to foster the thoughts of sustainable transport. The focus is on urban mobility, where we would like to help creating new innovative ideas. Innovative ideas most often come from young companies and entrepreneurs that have a lot of drive. We would like to encourage young companies and entrepreneurs in the field of urban mobility to come up with new solutions and introducing them into the market. With this video in particular, we would like to support you with a guidance on the technical development, focusing on vehicle concepts and chassis. We aim to give you a general understanding of what to take into account in order to create a vehicle concept and how to implement it. To do so, we have created a guide on design for small and functional micro vehicles. This vehicle is battery electric, but the principles are applicable on other drivetrains if needed. The vehicle uses a range of standardized and commercially available components to make the design as simple and effective as it can be. So the emphasis is on cost effectiveness and simplicity. But again, the principles are applicable to be used in order to create components in your own and to increase the vertical range of manufacturing if you wish to do so. We also would like to give you a basic design guideline for the vehicle development. One most important point are the requirements. They are specific to the different markets and vary from customer to customer, from use case to use case. So if you want to be successful, your vehicle have to fulfill these requirements, and you have to fulfill them in order to have a high customer and user acceptance. We also look at the vehicle concept in terms of modularity of use cases and, here to say, versatility. So with the same basic vehicle concept, we will look at one option for transport of people and one option for transport of goods. How to design a vehicle concept, Part A. In this section, we would like to give you a general overview on how to design a vehicle concept. This means we would like to mention some design principles and fundamentals in order to give you the basis to alter the vehicle concept that we are going to show you so that it meets the needs and requirements of your customers. We will look at the choice of materials, mechanics, dynamics and kinematics, production, joining, wheels, and also the adaptation to different regions. But before we have a look at it in more detail, we would like to figure out what a vehicle concept actually is. So, what is a vehicle concept? There is no simple or definite answer to this question, but we will try to figure it out. A vehicle concept is the absolute base of a vehicle. It is the design of the overall product and ensures that the vehicle makes sense and is functional. So it is the orchestration of several disciplines in order to make sure they play the same track, to speak metaphorically. So the different disciplines might be styling, exterior and interior areas, the packaging, the safety, the TCO, so-called total cost of ownership, the production, the suspension, the drivetrain, the energy storage, the NVH, so noise vibration harshness, the vehicle intelligence / ADAS, and also requirements. The latter being probably the most important and the base for the development of all disciplines mentioned. So we are talking about shaping vehicle characteristics in such a way that they will meet the requirements in the best possible way. So in a nutshell, we could say that a vehicle concept is the design philosophy and principal layout of a vehicle. We will focus on the structural and economical side of it because this is probably momentarily the most important part and would relate to the discipline of packaging. And we always have to bear in mind economic boundary conditions. Design guidelines. So let's have a look at these 6 things that we have listed here from top left to bottom right. And we start with the choice of materials. Now, the material choice has a huge impact on the overall vehicle and the vehicle performance. It has an impact on the durability, on the strength of the vehicle, and probably most importantly on the weight. You also have to deal with corrosion and protection to corrosion and also safety. And the material choice has also a big impact on quality, sustainability, and repairability. To give you an example, for the base frame, for instance, of a vehicle, we could choose either steel or either aluminium. While steel is very strong and very common in use, it is heavier than aluminium and it has problems with corrosion, so you need some corrosion protection. But in sustainability aspects, it's very easy to get, very easy to repair. Aluminium, on the other side, is not as strong as steel, but therefore a lot lighter. It also has not the same issues with corrosion, so it's a little bit less problematic in that area. But for sustainability aspects, you probably have to put more energy into the creation of aluminium, and the repairability is also an issue compared because not every aluminium alloy is as easy to weld or as easy to repair than it is probably with steel. Let's have a look at the mechanics and dynamics and kinematics. You usually want to have a low position of your masses, and this means that you want to have a low center of gravity, and you want to have a center of gravity also in the center of your wheelbase, especially while use. So you have to distinguish between the static and the sort of in-use center of gravity. And the reason for this is that we want to achieve the greatest stability of the vehicle possible and the best performance possible. Another thing that we have to think about are oscillating masses. So for instance, the wheel, also called unsprung masses, and they are very important for the comfort and NVH, but very, very important for the safety and also for the efficiency of your overall vehicle. and therefore always to be beared in mind. If you look at the production, we would like to emphasize that it is probably the best to have an easy and therefore also very safe manufacturing process. And the production is also to be very easy. So this is a key for low cost production of an overall vehicle, but also for later on repairability during the use. Also, what is needed is a high accuracy, because this helps with quality and also enhances the durability and sometimes the safety depending on the parts. If we come to joining or bonding, this is something we also want to take a look at. So joining has a huge impact during the production process and probably also beyond. So during the production, we could think of several things. For instance, adhesive bonding, which is very good because you have a low introduction of weight and it increases the strength and also the stiffness, but it takes time to harden. So during the time it hardens, you probably can't do anything with your vehicle in further production. Welding might also be an option for joining or bonding, which gives very strong joints, but is also rather time, especially energy consuming and very cost consuming. And also it needs to be carried out by trained members of staff. Another option might, for instance, be screwing or bolting, which is very easy to do, also in the assembly process, but also in the disassembly process, and might be therefore also something to be considered. So always think about the production and the joining method and what it will do to your vehicle later on. Wheels are also very important to look at because they have to be adapted to the road conditions that the vehicle will experience during its use cases. The choice depends probably on the speed you want to go with the vehicle and the loads that we see and the road surface conditions that the vehicle will operate in. So always bear the tires in mind, and this is something where you can change also the performance behavior of the vehicle quite drastically. Then we have, last but not least, the regional adaptation. The regional adaptation is quite important because you probably have, depending on the region, different user requirements or user needs you want to fit. For example, in some hot areas, it might be necessary that for this electrified tuk-tuk you want to fit an HVAC, so an air conditioning, so you increase the passenger comfort. In other regions, you probably need some weather protections because the weather is, let's say, bad in terms of humidity or rain, and therefore you need to protect your cargo, but also your people, and also parts and components of your vehicle. This might not only be related to water or humidity, but also to dust. So if you have very dusty regions that your vehicle will operate in, you would also need to think about how to seal off certain areas of the vehicle in order to keep it functioning over a long period of time and don't need as much servicing as a vehicle, for instance, without some sealing. Now let's have a look at our design requirements. On the left-hand side, you will see a figure that we will come to later on, and also on the right-hand side, some bullet points of the most important things. So requirements, we have learned earlier on, are probably one of the most important points regarding the conception of a vehicle. Every performance aspect of a vehicle needs to be described by one or a couple of requirements. And often you have a bunch of requirements defining one aspect. You sometimes will also have requirements that contradict each other, and you therefore need to solve them. So requirement management is key and very important. But what actually is a requirement, you might ask? Well, we try to figure it out. A requirement is, in this case, a technical description of an aspect, for instance, a part or a performance figure. And you need to meet this. So the description of this requirement is given in such a way that the requirement is quantifiable or actually measurable. Requirements can come from all different sorts of different areas, which is shown by the figure on the left-hand side. On the left of this figure, we see the internal requirements, and on the right, we see the external requirements. The vertical axis gives us the way the requirements are presented. So this might be either by documents, products, or actually people. Requirements can also be categorized. So three very common categories are, first of all, design requirements, minimum requirements, and fixed requirements. Desired requirements are something that is desirable to be met, but you don't need to do it. You don't, or you not must meet this requirement. But usually it will enhance the product's attractiveness to the customer. So therefore it makes sense to meet it if you can. If you have a minimum requirement, this requirement must be met and might be exceeded. And if they are exceeded, they might also enhance the product attractiveness to the customer. The fixed requirement are probably the most strict one because they must be met spot on. There is no margin for that type of requirement, and therefore you have to be on point. Something you always have to bear in mind are legislative documents. They are probably the most important requirements because they are mandatory and you need to meet them in order to get a vehicle on the road and approved by legal authorities. But you also have to bear in mind standards and the state of the art. If you develop a vehicle or a new product, it must always consider the state of the art to ensure that the latest knowledge has been used for its development. If we look on the product level, for instance, there can also be a lot of requirements. One example might be a product from a competitor. So if you want to get a new product into the market, you need to be on par or even above the level of your competitors in order to be successful. And therefore, you would need to know what makes the other product successful and which kind of things you need at least to meet or want to exceed, so which are the minimum requirements. And the process is called so-called benchmarking, where you actually look at the properties, or not the properties, but also on the aspects of the of the competitive products. If you look on the people level, you also have a lot of requirements there, and on the internal side, they come from different departments within your organization. For instance, marketing or production or engineering or styling or design. Well, on the external side, they might come from suppliers or customers. So, for instance, one supplier will tell you that he needs a certain kind of requirement and you therefore have to meet it. So, in a nutshell, you have to think about your product that you want to develop very carefully, and you need to do a lot of detailed research on the current standards and on the current regulations and legislations in order to get the vehicle into the market. Therefore, it is also quite possible to engage really early on with the regulatory authorities in order to get their help and to talk to them about the planned developments that you're going to take. Also, strategic partnerships with governmental bodies or agencies are, let's say, preferable because they can provide support and give you some opportunities and give you some some tips on how to develop your vehicle. The consideration of regulations for the vehicle approval is something you need to do and is essential. It also helps if you look at different markets to see which kind of developments with your regulation and legislative stuff in your target market might come up. And something you always have to check also from time to time during the development. And last but not least, it also makes sense to have rough target corridors for your vehicle, so you see, okay, whether you're going to meet this requirement or whether you're going to exceed it, and what is necessary to be done in order to meet the requirement or to get an exceeding area that you're sort of targeting. Let's move on to how to design a vehicle concept, part B, the example of the e-tuk-tuk. In the following section, we will go into detail on the design of the vehicle concepts and chassis by using the example of a battery electrified three-wheeler, our so-called e-tuk-tuk. And what you see here is an exemplary figure of it. But how do we actually start? Well, first of all, we remember the figure from before with the requirements, and there we saw in the internal layer of the people level that we did have different departments. And this method of the different departments is something we can apply to this very vehicle here. So we try to group things that are related to each other into groups or categories, and therefore get a structure on how to take on the vehicle. So let's see what we can find if we do that. We now see that the vehicle has split up in different groups and areas, and we basically divided it into that. Now finally, we will come up with the following main groups, which have some other groups available. So we will have something like the chassis, which is, for instance, something like this down here with a frame and also parts of the suspension. But we will also have the drivetrain, so we have our electric motor, for instance, but also therefore the energy storage system, which is the next point. And we have things like the body structure, stuff like this, or also here at the front, which is the driver compartment. And these groups we will call now domains. And we can go a little bit into further detail with our domains. So we see, I talked about the chassis, so the chassis will consist of our framework. This is the base frame down here. It will also be part with the rear suspension and the front suspension that we will see, while, for instance, the electric motor is rather on its own, but has to correspond with the battery and the battery management system, so the BMS for the energy storage. And if we look at the body structure, we will see the driver compartment, so this shield at the front, but also the seats. And we will also have the rear compartment. In this case, we will have 2 additional rows of seating, but it could also be a cargo compartment. And we also have to deal with a roof for weather protection, whether it's raining or whether the sun is shining. And also we will have to deal with the lighting of the vehicle. The wheels are also part, but they will be considered in the suspension domain. And if we do this in a sort of more logical way, we can come up with a sort of structure we're going to see next. Deriving domains for vehicle conception will give us this structure. And what we can see here is now that we have the e-tuk-tuk on top, and we divide it in our domains of the chassis, the drivetrain, the energy storage, and the body structure. And as we can see, we do have sub areas that will now show up, and these sub areas can also be divided again into sub areas. As I mentioned, with the drivetrain, we're just looking at the electric motors, so there is no sub area. The same is with the battery and battery management system, because we're not focusing on this area in this very sort of course, but this is done in other areas. So we will go through this now step by step and have a very detailed look at each of these little boxes. Design of the domains. We will now enter the domain by domain and step-by-step guide. The structure we use is always the same for all of our domains and all of our steps. So first of all, we will give you a short overview of what we're going to do in a domain, which input there is, what the process or assembly process will be like, and what the output is going to be. After that, we will take a look at the process of the domain to see which steps are necessary to finish this part of the electrified tuk-tuk. And after that, we will go through everything step by step. We will take a look at the necessary components, the tools you might need, and the process you have to follow. At this point, I would like to point out and emphasize that this guide is very detailed, but it will take you to think it through before you start off with your own vehicle concept. So this guide is more of an example than an actual instruction or manual. We will give you the basics, the principles, and the methods, but it is your responsibility to process it and come up with a working concept of your own. This said, let's start with the first domain and get into the vehicle concept of the e-tuk-tuk. Okay, so let's start with the chassis and the framework and the base frame. Now the base frame is the sort of foundational structure, an absolute base of the electrified tuk-tuk, and it's the part that everything else will be mounted on later on. So therefore, it is very crucial that it is the first component to be assembled and produced and will be used for anything that we'll do on later on. An input for this domain is a set of profiles. We use steel profiles. These are cut to length and cut to meter, and then they are assembled and they are welded. And on the right hand side you can see the output, which is this more or less triangular shaped base frame. So let's have a look at the process for this base frame. On the left hand side we see that it starts with the sawing of the profiles to length, then we put the base frame together, see if everything fits geometrically, and then we saw the profiles to meter. We will tack weld them to again then check the geometry, and then we will fully weld the base frame in one part, and after that we have the base frame and we'll do some quality checks on the welds and see how much the welding distortion actually is. So let's start with the first step of sawing the profiles to length. What we need in order to do that is that we have our rectangular profiles, in this case 60 by 60 millimeter steel profiles with 3 millimeters of thickness. We need a tape measure, a scriber, a saw, and a file. So we will mark how long our profile needs to be. We will then saw it, preferably bandsaw, and once it has been cut, we will deburr the cutting edges. The next step is that we take these cut profiles and we place them in the way that we have them actually on our plan to see if they fit and the geometry is all right. Check that the geometry is right. We will then take them and again use a saw, file, a tape measure, and scriber, mark where we want to have our emitter, and then with a machine cut our profiles to meter. The profiles we have cut to meter will then be arranged again according to plan, and we will see if they fit nicely and if the layout and the geometry are exactly in the way we want it. If so, we will proceed with the next step. In this step, we will then take the profiles and MIG weld the joints. We will do this only by tacking them in order to do some corrections afterwards if necessary. We will then check the geometry. For that we will use a tape measure, protractor, and spirit level, and check if everything is all right at this point. And if everything is all right and correct, we will then move on. If you find something that is incorrect, the joints are only tack welded, so there is the opportunity to disassemble and separate these things rather easily. But if you have completed this check and everything is alright, we will then move on with the next step. Now the next step again involves our MIG welding machine, and we will use it to completely weld the joints now. And the fully welding is something that we then have to check later on. So there's a quality gate that we need to watch. So we will check all the welding seams, if the welding has been performed correctly and if the seams are all in good condition and shape. And we also have to check the overall frame if there are any distortions. If the distortions are too big, you probably have to take some countermeasures in order to get rid of these distortions. But if they are within the tolerances you could accept, we are good to go and start our next process. Now the next process or domain is the support frame, which is based on our base frame and is used for giving a sort of floor panel and support structure for the roof and other parts, and therefore it is important for the protection of our occupants or cargo area and also the safety. So the input is, as we can see, again, some rectangular profiles made out of steel and some sheet metal, which is then manufactured and assembled. Once it has been assembled, we have basically our frame ready, where we can mount everything else on later on. So now let's have a look how this will turn out in respect to the process. The support frame has the following process that we see here. So we start with determining the geometry of the roof supports. We will then saw them to length, tack weld them, and check the geometry. Once this has been done, we weld them fully to the base frame. Then we will see what we need in order to determine the floor sheets. Once this has been done, we will cut them to measure and attach the sheets to the base frame. This is done probably by bolts preferably. We again check the geometry, and then we determine the dimensions of the support we need. Again, cut these to profile, tack weld them, and check the geometry, and then weld this support structure. Then we go for the determination of the geometry of the panels, manufacture the panels, and we'll then attach the front panel as well. So let's look at everything step by step now. So the first step would be to determine the geometry of the roof support. As we can see, we would again use rectangular profiles just for standardization and for making things a little easier, and what we basically need is just measuring tape and maybe a scriber. We have our plan, and then we know, okay, how long these things need to be, and they will be later on mounted vertically on our base frame. If we have determined the geometry, we will then move on to sawing them to length. So it's very similar to the base frame process, again using a tape measure, scriber, a saw and a file. Once we have marked the length, we saw it, and then we will deburr the edges in order to have a good connection. We take our trim profiles and use again a MIG welding machine. This MIG welding machine is then used to again tack these profiles onto the base frame, because as you can imagine, we will do in the next step a check of the geometry. So we have now these tack welded profiles. We again use our tape measure, protector and spirit level, and we look if everything is in the right angles, if everything is at the right position. If so, everything is fine. But again, if we see that some of the measurements might be incorrect, we have the opportunity to separate them rather easily at this point, or disassemble them rather easily, and then position them in the right spot, and again start the tack welding process and again check if they're in the right spot. And if so, we will then start with the next step. Now, the next step is again the full welding of the roof support. So we will use the MIG welding machine in order to have a fully welded seam here. And once we have done that, we again check if these seams are flawless and if they're up to our quality standards. The next check would now go for the determination of our floor sheets. So what do we need? We do need the base frame with our roof support structure, and we need some sheet metal. At this point, we reckon steel plate with a 1.5mm will be sufficient enough. I could go a little less regarding the thickness, but it depends on which kind of use case you will have with your tuk-tuk at this point. And again, we need a scriber, and we do need a bit of measuring tape. And what we do is basically we take the base frame, draw the lines of our sheet that we want to have, and we have to pay respect to the parts where we have the pillars for the support frame, and to mark them here as well. So if we have done so, we will take this scribed sheet of metal and we will start cutting the sheet to measure. Now there are different areas how you can achieve that. We're going into detail, but things you might need are tin snips, files, drilling machines, a center punch, or a hammer, for instance. And you're then cutting along the edges that we have just marked, and then we will end up later on with a shape similar to this one that we then can use and place on top of our current frame. Now this is what the next step is all about. It's the attachment of the sheet to the base frame and basically creating the floor. So we have the base frame structure with the support structure in place, and we have our sheet metal which we will place on there. Now there are different ways how we can join these things. In this example we are opting for bolting because we can then later on detach it, but for instance you could start welding, which probably has the disadvantage of being quite distortionful, but the other thing that you could imagine is also to glue it, to use adhesive bonding. But in the case of bolting, you would need a file, again a MIG welding machine, drill, tap, hammer, and center punch. And you're going to mark the areas where you want to actually bolt it to the floor. Once you have done so, we're going to connect the base plate by, in this case, welding the nuts to the base frame, and then we can screw it on there or bolt it on there very easily. So this will be then the last step that we need to take, the bolting of the floor. The next step would then be again to check the overall geometry. Depending on the joining method, it becomes more important or is actually less important. So you have the overall base frame with the support structure and the connected base plate, and we again use a tape measure, protector, and spirit level, and we see whether the welds are totally correct, if our measurements are still within the correct spaces, and then we can proceed, for instance. But if we see that there is something incorrect, it now becomes a little bit more complicated, but we recommend strongly to do it at this point, to do a correction, because if you do it later on, it probably becomes even more hard to do the correction. Now the base frame is now covered, and we are looking at the determining of the dimensions of the support, which we will have at the front. So this is where later on parts of the driver compartment will be mounted on, but also the steering fork. Again, we will use the rectangular profiles that we will now cut in the following process, as you could imagine. Again, 60 by 30 millimeters and a thickness of 3 millimeters, so there is no variation within the profiles we're using. We need the measuring tape, and again we will determine the geometry according to plan, and we'll look at the attachment points that we will want to have. Then we will again saw these profiles to meter, process should now be well established. We'll take the tape measure and the scriber and mark the areas that we want to cut, and then we use our bandsaw. And again, deburring the edges in order to have a good fitting. Once we've done that, we position these support parts on our base frame, and again with a MIG welding machine we will start to tack weld only. As you can imagine, the next step would be a check of the geometry. So we will look again with the tape measure, protector, spirit level if everything is in the right spot and at the right angles we are looking for. If this might not be the case, we have now again the option to correct it rather easily. And if everything is right, you probably have guessed it, we will weld the support structure again, and obviously we will check for the welding seams if they're all right and if the quality is up to our standards. Now this step, we first of all want to determine the geometry of the front panel. So we have our front panel support, and we will now use something to make a template with. So either cardboard or wood, for instance, a measuring tape and something with a straight gauge. And we will then, as we can see here, use this and our support, which is now seen from above, and create the template we will then need in one of the further steps in order to create the actual front panel. So we use the cardboard to place it on here, and then draw the lines we need, and then we cut according to the lines and create the template. So we end up with the desired contour we want to have. Then the next step would be the manufacturing of the front panel attachment points. We would need some nuts, for instance, and the support panel structure. We would recommend to use a drill, a tap, and a MIG welding machine, and then we will look for points where we want to actually bolt or attach the front panel to, mark them, drill a hole through, and then we will use the nuts and weld them to the structure so we can later attach our panel to that. Now we're at the step where we will again need our template that we did before, because we're now going to manufacture the front panel. So we have the front panel support, the material for it, which could be anything, maybe some sheet metal if you want to have it very durably and very strong. And we then have our template tools you can see over here, and we now start to shape the front paneling according to the attachment points and the template that we just did. And if we've done so, we can actually bolt it to this structure. Again, a quality gauge. We're going to check for welds and distortions before we do this, but I think this has been quite repetitive at this point, so you already know. The next domain is the domain of the suspension, and we're looking here at the steering fork in particular. And the steering fork also bears the springs for the front, and the spring stiffness is something very, very important, because it has to be adjusted to, for instance, the weight of the vehicle and also the road conditions in order to prevent failure. So what we're looking at is the spring rate, the maximum travel length, dynamic wheel loads, and an example calculation. What you have to bear in mind, it's just an example. We're not going through a sort of detailed formula or actual calculation at this point. If you're more interested in that, we would recommend you to do it on your own, but this is sort of basic stuff. So at the very beginning, we would need to calculate the spring rate, which is very crucial for the selection. And this depends obviously on the total weight of the vehicle. Then we have the maximum travel length, and we will now say that the maximum travel length of the fork spring is set to 80 millimeters for this vehicle. So this value is made up of the static preload of the spring, which acts as a force on the spring due to the weight of the vehicle when stationary. And then we also have the dynamic component, which is applied by driving over uneven surfaces, for instance. This dynamic component is referred to as a dynamic wheel load fluctuation. We currently assume that this is plus minus 50% in uneven road conditions. And in order to protect suspension failure, we have a safety factor of 1.4. Sorry, not 1.4, but 1.5. And this is how we think we will apply the forces. And in the following, the spring stiffness is calculated according to these assumptions. And we have a static mass on the front wheel. We will say that our tuk-tuk has a total weight of 1,100 kilograms, and about 21% of that are on the front wheel, according to the center of gravity and the way how it is related to the wheelbase. So the maximum travel of the fork is set to 80 millimeters, so 0.08 meters. And if we're going to calculate that, we will have the mass of the front wheel times the gravitational force times the safety factor, divided through sort of travel rate that we want to have, and we would end up at this point with roughly 42,490 Newton per meter. But again, attention, a value is specified above for this very example, and you need to adapt it to your individual design and to your individual use cases you're dealing with. So the vehicle weight, including payload, might deviate from the concept that we have presented here, and therefore you have to check that with you. So that's why we have the note down here. So what will be the input and what will be the output, and what are we going to do? Well, as an input, we will use again some rectangular profiles, and we will mount them here at the front of the base frame, and we will end up then later on with this added steering fork. Now the question will be, what does the process for that look like? Well, the process is now a rather lengthy one in this case, which we're going to see right now. So we begin with choosing steering angle, and we will determine the handlebar height, the calculation of the length of the fork. We will then do a selection of the fork, selection of the head tubes. We will then have a look at the head tube mounting profiles, saw them again to the length that we need, create the welding, check if the welding is right, adapt the profiles, check weld some profiles, check the geometry, then weld profiles to the base frame, and again weld other profiles to the base frame, and then we will adapt the head tube, tack weld them to the whole profiles, and check again the geometry, because this is now very sensitive because we're using it for steering. And then we will fully weld the head tube to the profile. Then we'll press the bearing into this kind of headset, install the fork, and then select the handlebars we need and attach them as well. So a rather lengthy process. Let's start with it. So this is now the first point. We would need to choose our steering angle, and this is something you can do on your based on your preferences. Obviously it has an effect on the wheelbase. The smaller this angle is, the longer the wheelbase will be, and vice versa. So we probably need to calculate a pencil a bit of paper. Usually we can give you as a kind of guidance that the tuk-tuk would have something like 45 to 60 degrees regarding this angle, and this is what we will deal with in our examples. Now the next step is then to look at the compressed state of the steering fork. For instance, if we go over a bump or if we have a lot of load on the front, we have to make sure that this is still sufficient enough, for instance, regarding the clearance that we get here. And again, please bear in mind we're dealing with a part of the steering here, so it is very sensitive. We can have some influences on the steering and therefore on the brakes as well. It should always be beared in mind that if you have a lot of load on the front tire, steering becomes way harder. It will also suppress understeer, but you also increase the chance of tipping the vehicle over because it's just a three-wheeler. So make a wise choice depending on the road conditions you're driving in with the steering angle at this point. After you've done that, we're going on to the determination of the handlebar height. Well, the handlebar height is now something that has to do with ergonomics. As we can see, we need a certain height above the base frame. Imagine there's a person sitting. How upright is the person sitting, and where shall the person position its arms? This is all something that you need to take into account. The height range that we would sort of recommend is something in between 600 and 700 millimeters above the base frame, as we can see here. But again, it depends on your use case and the anthropometrics of the population or the customers that you are going to have as your main customers. And if you want to be very accurate, you can check it yourself and have a look if you feel comfortable with that height of the handlebar. For the calculation of the fork length, we will need some measurements that are given by our geometric constellation, which you can see over here. So everything you see in this figure is also listed on the right hand side now. We have here an L for saying it is a length, so L1 refers to this one over here. And what do we need to do to get the installation length L2 in this case? We can calculate it by specifying the handlebar height, which would be L5 in this case, and selecting the front wheel radius L1. And we also have to establish the ground clearance, which in this case would be L6. And going on with that, we will also look at the angle that we need to have, the steering angle, which is alpha, and additionally the possible range of the triple clamp spacing, which is here at this top, which is L3, and the top triple clamp L4, which must also be taken into account, and which will vary depending on the fork and also vary on the handlebar model that you are going to choose. And then the length L2 is calculated with that little formula over here. So L2 equals L5 plus L6 divided by sinus of alpha minus L1 minus L3 minus L4. Again, the actual values might be different depending on the layout that you have chosen. Now the next step is to select the fork. What you have to consider is the travel again, or the deflection, when the suspension is in the compressed state. As you can see, this can lead to the fact that the front wheel might actually have contact with one of the support frames, so bear that in mind. So it does not happen, because this would then obviously be bad for the overall stability and safety of the vehicle. And select a suitable fork based on the sort of minimum installation length that we have just talked about, and yeah, then we will look further on the spring rate. Let's move on to the selection of the head tube. Now the head tube is something that we see over here, which is in this case currently not going to see the presenter. Sorry for that. So it's placed over here, and this is now the front view of that. So it's basically just something where we can later put a bearing in. So we have to select a head tube that fits the sort of spacing between the throttle clamps and has an inner diameter which also fits to the bearing that we want to choose. And the next step would then be to have the head tube mounting profiles. The head tube mounting profiles are again the rectangular profiles that we're going to use as seen before, and we will also have a tape measure at this occasion, and we're going to measure what the distance is that we need to cover as seen in this figure. As you can imagine, we're then proceeding by sawing the profiles to length. So again, we have a scriber to mark it, and then file and saw, and do so as done before. So once we have sawed it, we will deburr the sawing edges for fitting perfectly and nicely. After that, we will proceed in a very similar way to the base frame before. So we will tack weld this part to the frame. So we are welding down here, and again using here a MIG welding machine. And then we need to look at the adaptation of our support profiles to take the profile that we just mentioned. So we will cut again our profiles so that we can see, like on this area, that we get this triangular shape to team up with our strut here. And we deburr this again as mentioned before. We will then tack weld these support profiles as well to the frame, in this case the base frame. And once we've done that, we obviously have to check the geometry. So we will use again tape measure, protractor, and a spirit level, and see if it is in the right angle that we are aiming for, if it's positioned in the middle of the whole base frame. If not so, we can again correct it. So this would be the next step. If we see that there are things that are not up to our standards and incorrect, we try to correct it. Once we have settled that everything is in place, we will then weld the profiles to the frame. So we start with this profile down here at the base frame, and then work our way to the support profiles 2, 3, and 4. Weld them again down here as well, and up at the top. So this is what it looks like from the very beginning. Again, sorry, not from the very beginning, but from the front. Once we've done that, again, check the welding seams if they're up to standards, and if not so, correct it. Next would be to adapt a profile to the head tube. So what are we going to do just to make that sure? We do have our head tube, which is depicted over here. We want to have that on this profile. So we need to create this adapter. We use our head tube, and we use a frame with support for the head tube. Again, the sort of usual tools that we're going to use. And we're going to transfer the geometry of the head tube to the profile to have a 1x1 cutout in order to make sure that this will fit nicely and can actually be joined later on. Second stage would then be to cut out the marked geometry. You might use a pencil for this, or you just might use a set of files, depending on the size of the head tube you need to cut out of the profile. Once we have that, we move on and try to attach it. So this is now look from above, or a view from above, and we again tack weld this to the profile, and we can here see that this is now also in the side view visible. Now, as you can imagine, because it is very sensitive, because we're now defining basically our steering axis, we have to check the geometry very properly at this stage. So again, take out the tape measure, the protractor, and spirit level, and check if there has any, or if any distortion has occurred during the welding process, and if the measurements are according to plan, what we've talked about before, and if it might be incorrect, corrected by separating and then again welding this piece together. Once everything has been established that it is in the right spot, we start welding again the head tube to the profile using the MIG welding machine, and this is a very simple process we've done before quite often. The next step would then be to have a look at the bearing, because we need to have some smoothness and some security in that. So we take the bearing, so we have an inner bearing and an outer bearing shell, and they must be mounted separately into the tube. If you have the right dimensions, you might use a hammer to just insert the bearing parts. Usually you would need to have a press, as we can see here, and we have one part from above and the one part from below, which we would then insert. And by the way, only the outer bearing shell needs to be pressed into the frame, not the inner one. This step has a second part. So we have an outer bearing shell on each side of the steering head, and as mentioned, use a press or a pressing tool to do this. On me, you can do it with a hammer, but the danger is quite high of actually damaging the bearing shells at this point. The third stage of this step is then that the inner bearing shells are inserted, and once this has been done, we can move on to the next step. The next step is now the installation of the fork, again divided into several stages. What do we need? We do need the fork, and we do need the frame, and we have a hexagon socket screwdriver and an open-end spanner and saw, for instance, and then we insert the fork through the lower part, and then we have the fork crown up here that we will then enter. The second stage of this step would be that the tube can now be shortened to the length that we want to have it. So we're talking about this bit here, which will, can't see on the laser pointer, okay, this bit here, which will then protrude up here, so you can cut it to length depending on what you actually want and what you need. It's not necessary to actually do this. Going on, we have the third stage of our step. We might need some spacers, so the spacers are shown here, also one down below, in order to protect the bearings. It might be needed. We recommend using it. And the fourth step, which is then also the last, is that we tighten everything according to the manufacturer's instructions, and then we're done. And we now have the base frame and the front fork installed. So as mentioned before, if you want to trim this piece which protrudes, which do not need to do, but you can do, we will now mount on one of the handlebars. The handlebars is things that you can get from stock. The selection of the handlebars is something, you need to consider regarding the ergonomics. So you can either choose your own ergonomic preferences, or this is something that can be fitted in respect to the customer requirements or customer needs, what they actually want. Now, if you have selected your handlebar, you just mount it on top of that pole. So we have the fork, the handlebar, clamp, and we need a screwdriver and an open expander. And the process is actually very straightforward. So we now have also a possibility to actually steer our fork. Again, at this very end, please make sure that you, if you didn't before, check all the welds, check all the distortion, all possible distortions. But as I mentioned before, this is probably something that should be done in between in order to correct it as early as possible within the process. The next domain we're going to look at now are the wheels. The wheel assembly and mounting for the tuk-tuk is something we have to take into consideration. So we have one wheel at the front and two wheels at the rear. As we can see, we might have different kind of tires, so maybe something like a motorbike tire at the front and something like road or passenger vehicle tires at the rear. Therefore, we need different rims. These two things will then be joined with a machine. You pump up the tires or inflate the tires, and then usually you should look if they need some weighting in order to run smoothly. The process that we're going to look at looks like this. So at the very beginning, we have to choose a front rim according to the steering fork. Once this has been done, we will choose a tire according to the front rim, and we do the similar thing with the rear. So we choose a rear rim according to the load needs, and then we choose the rim according to the tire. We mount the tires, front and rear tires, to the according rims. We will inflate the tires, and then we'll try to balance the tires for better stability. So let's start with the first step of that process, which is choosing a front rim. You just need the steering fork and the tape measure, as shown here. The spacing in between, that is the important thing. So we have to measure between these, let's call them damper parts here, and the steering fork. We also have to take into account the type of axle that we're using and the type of braking. The highest brake force is usually at the front, and if you use a brake disc, you have to fit a brake caliper on there as well. So this has to go with the rim and the tire in that space in between. So please make sure that you add this to the sum. Or if you use drum brakes, which are part of the rim itself, which is also something you can go for, then you obviously don't have to take that into account in here. So choose the rim that you actually want. The bigger the rims are, better they are for ride quality. The smaller the rims are, the less problems you have with possible collisions with the base frame if you have a high travel rate with your front suspension. The next step will then be choosing the front tire according to the rim. Just look what is available. Make sure that the tire can take the load you're actually going to plan to put on it, and also make sure that the tire is actually capable of going the speeds that you want to use. the tuk-tuk in. Now the next step would be to choose the rear rims. This is something that you have to take into account with the load. Bigger rims again, bigger wheels in general mean a better comfort. So this is something you take into account. And then you choose the rear tire according to the rim in an analogous way as we've done with the front tire. The next step is then mounting the tires on the rims. So we need our tires, we need our rims, and we need a tire fitting machine. That makes it the most easiest for you. We need a tire lever and we need some tire grease in order to not damage either the tire and the rim itself. And you fit the tires on the rim according to the instructions of the tire fitting machine. The next step would then be to inflate the tires. Make sure again to check which kind of load the tires would take and which are the corresponding pressures the tires would need. High tire pressures usually help you creating or coping with high loads. The lower the tire pressure is, the smoother the ride will be, but also the wear of the tire will be bigger. So this is something where you have to find the best compromise for your clients at this point. And if you've done so, the tires will be balanced. So you will need a wheel balancing machine at this point, where you will actually add a little bit of weight on the rim. So tire is nicely balanced. Do this for the front and do this for the rear wheels, based on the instructions given to you by the machine. And yeah, again, a quality gate here, so check the rim and the tires for a proper fit. It's the only contact patch that you have to the road, so this is a very safety or a very important safety feature here. If you move on, we are heading towards the chassis suspension and now the rear springs and dampers. There is also some calculation to take place. So we have the calculation of the leaf springs and the dampers, and the key consideration that we do have here is the maximum deflection of the safety rates. So we are now talking of leaf springs. At the front we do usually have coil springs, so there's a slight difference in the way how we calculate it. We need the modulus of elasticity, the thickness and the width and the length of the leaves we're going to use, and again we say we want to have a maximum deflection here of 80 millimeters. We will calculate the force we will have on our springs and therefore our spring stiffness, and then we can calculate the thickness. Without going into details, the rough thickness of this spring is somewhat about 31 millimeters. Now the car isn't damped, or the vehicle isn't damped at this point, so we need some damping at the rear because we know that there is some load on there, and once this starts oscillating it might become very nasty, so we have to dampen the oscillations that might occur. And we have our critical damping. The formula for this is probably well known. And we want to say we have a damper constant of 70% of critical damping for the optimum. Right, and at this point the critical damping would be, well, the critical damping constant would be at around 8,250 kilograms per second. Note, again, these values are now based on a sort of fictitious three-wheeler with 1,100 kilograms weight, and depending on the geometry you have and for the weight and load distribution of the tires, these things will change, and you have to calculate them on your own for your own concept. Let's have a look at the process, because this one is again a rather lengthy one. I will go through it from the very beginning on. So we start with the calculation of the center of the rear axle. Then we will choose leaf spring and damper. We will mark the positions of the leaf spring on the base frame. We will calculate our height offset for the attachment of the springs. We will saw our profiles to length, tack weld them again, check the geometry, fully weld them, and then mark the positions of the damper on the base frame, calculate the needed offset for the position of this attachment. Then we will look at the profiles, saw them to length, tack weld them to the profile, check again the geometry, and then weld the profiles to the base frame. And then we will take care of drilling the holes for the attachment. We will bolt the springs and dampers onto the frame, install them, and again check the geometry if it's what we wanted to have. Then we choose the point for the damper and the spring, create an attachment part for that. Then we will weld the attachment parts to the U-bolt plates. And then we will assemble the rear axle on the leaf springs with our U-bolts, and we will also attach the damper to the U-bolt plates, and finally check the geometry and see if everything is right. So let's start that process and go ahead with the first step. The first step is to calculate the center of the axle. For that we would need the base frame as we have it right now, tape measure and scriber, and we would measure the wheelbase from the center of the front axle, mark the center of the rear axle on the base frame. So this is our rough approximation of what we need to have for the wheelbase. Now we will choose a leaf spring and damper. So as mentioned before, you need to calculate the spring according to the chapter. You get your length, you get your height, and you get your width, and also calculate the damper corresponding to the instruction we gave before. Now, the position of the leaf spring on the base frame is now very important. Usually within the, let's say, minimum, you want to position the axle laker on. So make sure that the minimum or the lowest point of the leaf spring is right underneath the point that has been marked on the base frame for the wheelbase. So again, use a scribe of that one. The leaf spring usually comes with some shackles, and you transfer their position onto the base frame and mark it there, and then this step is finished. Now the next step would then be to calculate the height offset for the attachment. We obviously have a deflection rate of the spring, and in order to have that amount of travel that we actually calculated, it makes sense to have a little bit of an offset. It might just be, and this is not necessary for you because the shackle's already provided, but it could be that that you need to do this. So once the height has been calculated and established, we recommend using again profiles to get the right height. So we would use again the rectangular profiles we've seen before with 60 by 30 millimeters regarding the section, and we will use the tape measure, scriber, saw, and file. We will saw the profiles to length according to the height that we've just established, and deburr again the edges for a good fitting. Then we will tack weld the profiles to the base frame, again using a MIG welding machine at this point. As is mandatory afterwards, we will check the geometry, so just make sure that this is actually on the sort of position that you actually wanted it to be. If there might be some distortion, okay, start to correct it, and if everything is right, we can then move on to welding the profiles fully to the frame. Again, once this has been fully welded, please check the seams if they're up to standards and up to quality. And then the next position would be, or the next step would be to position the damper. The methodology is very analogous. So position the upper part of the damper on the cross base of our base frame, and you should mark the position on there. If necessary, it might be that we have to have an offset here as well. Again, it might just not be the case, but we're currently taking care of that. So as we had with the leaf spring, we might need a little offset over here. And if we want to have that offset, just once you've calculated it, use again a rectangular profile, 60 by 30 millimeters. Mark your length you need, saw it, and then deburr it. And if you have done that, the process commences with the tack welding to the base frame. And as usual, after that, we will have also the check of the geometry. If you see that the geometry is correct now, the full weld will go on. And again, we have here the quality gate where the welding seams are checked. Now we have everything we need in order to proceed with the mounting process. So we will drill some holes for the mounting or attaching. So we would need the base frame with the attached parts to it, a punch drill, and probably tape measure. So we would ask to measure the attachment points that you would need for the shackles and for the dampers. Then they are punched, and once that has been done, they will be drilled. So we have the holes that we can use. In order to ensure that the screws go through nicely, please deburr all the drilling holes. The next point will then be to bolt on the springs and dampers onto the frame. So there are quite a lot of components we need at this point. Obviously we need the base frame, we need our dampers, we need our leaf springs, we need our screws, washers, nuts, and screw locks. We do this on the left hand side and on the right hand side of the vehicle simultaneously. The tools we need are the socket wrench and a torque wrench and some spanners. The process is actually very quite straightforward. So you fit the bolts with the washers and the holes and the screws, secure then the springs and dampers. Turn the screws with the torque wrench so the torque is correctly. Please make sure that you're not overdoing it, so make sure that you're within the limits given by the screws. Once you have finished this process, we again have to check for the final geometry. So what do we want? We want to make sure with our tape measure that the minimum or apex of this leaf spring is still underneath the point that we calculated. And if there are some incorrections, there is now the best spot to actually correct them. Let's move on to choose the point for the damper on the spring. We recommend that it is as close as possible to the actual mounting point of the rear axle. So you just check, okay, where it is going to be. Things to be considered here is the angle that you actually create with the damper. The best thing obviously would be to have it vertical. I mean, it would probably not work, but the little angles, if you would have something like this here, have the problem that you have basically two directions of the force. So you might end up with some stick slipping effects, and therefore the damper doesn't work as effectively, and yeah, probably wears out quicker as you want. So therefore we would recommend to try to mount it as steeply as possible at this point. Once you have chosen that point where to place it, we move on and again use a rectangular profile in order to create an attachment part for the damper on the U-bolt. We need a tape measure, scribe, a saw and a file, and again mark the length, cut it into length and then deburr the edges. Once that has been done, we will weld the attachment point to the U-bolt plate, and as you can imagine, at this point we do not really need to do it with a tack weld first. That's just for securing, but you can just weld it completely straight away. And again, check the welding seams. So in the very end we will end up with something like this. We have our U-bolt attachment point here, and we have this attachment area for our damper. The next step would then be to assemble the rear axle on the leaf springs. We haven't talked about the rear axle yet, but this is something that we will do. So we have the base frame and the rear axle with a differential and probably also the motor on there. Tools that we're going to use are the socket wrench, the torque wrench, and the spanner. We secure the rear axle with this U-bolt on the leaf spring. So first of all, you place the U-bolt on the leaf spring where you want it to be. Then you position the rear axle. Again, look that the center of the rear axle is right underneath the center that we just marked for the wheelbase on our base frame, and then secure the axle with the U-bolts and start to tighten them. And if you've done that, we look at the attachment of the dampers to the U-bolt plate. Again, because we have a hole in there, we can just screw it onto the attachment part and finally fasten it with the torque wrench set to the according torque. And then we do have a rather complete rolling chassis at this point. So we do have the base frame, we do have the steering fork, we do have the rear spring with a damper and with a rear axle, and if it is all within the sort of accuracy, now the wheelbase should be as calculated. If you see that there's something not correct, please correct it, but because we had all the quality gates and checks in before, there should actually be no huge discrepancy between the actual vehicle at the moment and what you have calculated. So let's move on to the next domain. Now let's have a look at the domain of the electric motor. We're going to calculate and select an electric motor as well as a reduction gear, so we're going to manufacture them, but we're selecting them from the range that we have available in the market. The engine is an AC engine or motor, and therefore we need an AC-DC converter. And for the electric motor selection, several factors play a decisive role in selecting the right electric motor. The aim of the motor selection is to provide the motor power required for the designed vehicle concept. The factors influencing the determination of the motor power include the maximum vehicle weight, consisting of the vehicle's own weight and maximum payload, the vehicle's intended climbing ability, and the air resistance of the vehicle concept. The factors mentioned influence the driving resistance that occurs, which must be overcome by the engine power, obviously. Another important factor in the engine's design is the intended maximum speed of the vehicle. As it is an electric drive, in any case, there is no need for a multi-stage gearbox. Shifting between forward and reverse gear is realized by reversing the polarity of the electric motor and is already provided for in most electric motors available on the market, so that a dedicated consideration is not necessary. However, by eliminating a multi-stage gearbox, the design of the motor and the reduction in gearbox directly defines the maximum achievable top speed. For this reason, the reduction gearbox and electric motor must be selected accordingly to match each other. Power requirement calculation is generally based on the greatest demand from a number of different requirements. The first requirement may be to be able to achieve a certain speed in a certain time. This case is not relevant for the present case of the simplest possible vehicle concept. A second requirement may be to be able to reproduce certain dynamic driving characteristics, maximum speed, maximum gradient, etc., with a vehicle performance. A third criterion may be to be able to overcome a certain curb height with the vehicle from a standstill, for example, to have sufficient vehicle power to overcome a certain height of a step. The formulas for the last two design requirements are given, but not shown here, and we will go through it just by thought. So we have the overall vehicle mass, which is 1,100 kilogram, and we have the calculation for the several resistances we have. We have the rolling resistance, we have the air resistance, and we have the inclination resistance, and we have a total drag that results out of it. Now, since the electric machine has an efficiency, the electrical power actually required must be taken into account. So we have the efficiency, and currently we estimate that we have a total vehicle weight, including the payload, of 1,100 kilograms, and a maximum top speed of 50 kilometers an hour. We are sort of approximating the drag coefficient by 0.4, and yeah, we have a frontal area of about 1 square meter. The gradient that we have is 12%, and the efficiency of the electric motor is assumed with 0.85. Now, if we do all these calculations, we do get the total resistance of 1,470 Newton. As mentioned above, the required motor power depends on the driving speed and the total resistance forces. It should be noted that the vehicle should not be designed in such a way that the intended maximum speed can be reached at maximum inclination. So, as this leads to significant oversizing of the drive unit and therefore higher costs and also higher weight, and therefore a way larger dimensioning of the battery, which in turn has an influence on the cost and weight. Instead, the vehicle is designed in such a way that we can achieve the targeted maximum driving speed on level ground and still reach 25% of the targeted maximum speed with a maximum load and a maximum inclination. So if we do that, we can calculate our required drive power of 2.2 kilowatts at this point, and the required drive power for the inclination is something that we have with 5 kilowatts. So the required motor power is now determined using the larger of the required power sums, so this would be 5 kilowatts, and if we assume that we have an efficiency of 85%, so 0.85, we come up with an electric power of 6 kilowatts that we should have. Now, the motor selection needs to be carried out individually by you and taken into account the individual vehicle concept. The weight and climbing ability are particular major influence regarding the region where you operate the vehicle, and therefore has to be done on your own. If you look at the reduction gearbox selection, since a multi-stage gearbox is not in use at the moment, we just need a reduction gearbox. And this has to fit the engine speeds, and the layout of the reduction gearbox is based on the maximum speed of the electric motor, and which is reached at full power, as well as the radius of the tires, targeted maximum speed of the vehicle, which is also achieved by taking into account the power limits. The current assumed maximum motor speed is 6,000 RPM. We have a wheel radius for roughly 14-inch rim of about 0.3 meters, and the top speed is again 50 kilometers an hour. So the rotational speed of the wheels would be something like 445 revs, and the calculation of the reduction speed is then the revolutions of our electric motor and the revolutions of our tires at this, or wheels at this point, and so we see that we have a reduction of ratio of 13.5 that we want to have. Again, you have to take a look what this actually means for your vehicle, what your boundaries are, what you want to set the vehicle to, and perform this in respect to the requirements that you have. Okay, so if we bear that in mind, that we have the motor and converter, the influence of the motor power, the power requirements, and then the sort of given values, we can choose a motor from the market. And if we do so, we then have to install this motor, and this is what we're going to look at on the next slide. And this is the electric motor installation. So we choose the electric motor, we choose the reduction gear accordingly to that motor, and then we attach the motor and the reduction gear to each other, and then we will saw some support brackets for the motor. We will attach the motor to the support bracket, and then we will make a connection. The bracket connection is then welded, and then we will attach the reduction gear to the differential and weld the brackets to the rear axle housing. The first step now will be that we choose a motor. I mean, we have talked about the calculations before, and just look what is available on the market that comes close to the figures that you just calculated, and make sure that you also know how big your engine is at this case, so how long, how wide, and how thick. Then moving on, once the motor is chosen, you have to choose the reduction gear. Again, the calculation was explained earlier on, and this is also commercially available usually. There are some motors that already have a reduction drive in them. There are some reduction drives that already have a differential in them. Just look what suits you best. We recommend using a differential. It's not completely necessary, but due to cornering abilities and comfort and also driving safety, we would recommend using a differential. So now the next point would be to attach the electric motor to the reduction gear. Two things that we need here, obviously, are the reduction gear and the electric motor, and some screws and some screwdrivers. And the attachment is rather simple. Please make sure that all the bows are tight with the correct torque. Next thing will then be to saw some flat aluminium steel pieces in order to create a support bracket. We recommend that you use flat steel thicker than 3 millimeters at least. Again, we need a tape measure, a scribe, a saw, and a file. This process is very similar to using to the one that we used for cutting the profiles. So we're measuring the steel, make it sawn into the pieces that we need, and then we deburr the cutting edges. And the next thing then would be to attach the e-motor to the support bracket. Now the support bracket is this, what we can see here, so it's basically just surrounding the electric motor. So we need the motor, the reduction gear, the trimmed flat steel parts, and sheet metal. We have some tools, screwdrivers, tape measure, scribe, saw, and files. So if necessary, we need to make an adapter for attaching the motor to our bracket. This is what we need the sheet metal for, and then we attach the electric motor to the trimmed flat steel bit. If we move on, we are looking at sawing the flat steel for the support bracket. So we're measuring the distance between the trimmed flat bar and the differential of the rear axle, and therefore we know which kind of dimensions we need, and we mark them on our piece of flat steel. If we have done so, we move on and saw that into shape and deburr our cutting edges. And then we need to weld the bracket connections, as you can see. So we have our rear axle here, this is our support bracket, and now we just weld it onto the rear axle to have that piece fully connected to it. The next step would then be to take our reduction gear with its attached parts and attach that to the differential. So these parts are already welded to the rear axle. Now here comes this unit we have assembled before, and we attach it to the differential at this point. Then we have the open connection points between the brackets. So we need again our MIG welding machine, and we're now welding these areas so that they are fully closed. Again, check the welds if everything is fine. Please also check the welds over here, and if everything is done correctly, the motor should run smoothly. We would ask you to test this first of all, and if it has been tested successfully that the motor drives smoothly, this part is now completed. We're now moving on to the domain of the battery and battery management system. We're going to do this not in too much detail. The battery design and the selection for the electric vehicle are key considerations that we have to take into account, especially for capacity and power requirements. And again, we're using stock solutions here. We're not creating anything from scratch. The battery design, there is the question, what is the sort of preferred battery? We recommend using a battery with a housing and also an included BMS. If you don't have a housing, you probably have to design it, but this shouldn't be too much of a problem. The case we are calculating with is that we say we have a required range for each day of 100 kilometers. So this will then help us to calculate the targeted capacity, and the average speed we think that we're doing within that day is about 30 kilometers an hour with a gradient of 2%. So again, we have our total forces regarding the drag force, the rolling resistance, air resistance, inclination forces, and the given load cases, and we then can start to calculate what might be necessary regarding the total force, which we have over here. Then we create the amount of electrical power that we would need, and then with the efficiency grades and the time of use, we can end up with the energy needed, and this would then be the energy that we at least, or the capacity that we at least need to have in our battery. Again, watch out what is available on market, and try to find something that is as close as possible to your needs. Again, please verify your parameters and do the calculations regarding your individual use case. So the battery installation is therefore also a rather straightforward process. It just consists of 2 steps. So calculate the battery capacity and select a battery, and then make an adapter for the battery and attach it. So the battery calculation is something that we just talked about, how this can be derived. And in this very case, we came up with 2 batteries, and these 2 batteries are stored in the area of the driver compartment, and the final seats are actually placed right above that. Again, it's preferred that the battery has a housing and that the battery has also a battery management system that comes with it. Once we've done that, we have to attach this to the vehicle. To do so, we need to make an adapter for the battery and attach both. So we need the battery, we need our base frame, and in this case we refer using some sheet metal. Around 1.5 millimeters will do. The tools we need are the screws, screwdrivers, tape measure, scriber, saw and file. And again, we make a template, and then we will cut out the sheet metal needed. The sheet metal is then folded into the right angle that we want to have. With a punch, you show the position of the sheet metal brackets on the base frame. You drill through both the bracket and the base frame, and then it is secured via nuts and bolts. And via that, you can adapt to any kind of size of your battery, and you can also adapt to the capacity needs based on your use cases. If you move on to the body structure, we look at the driver compartment, and the driver compartment is a very important thing because this is where your customers and the drivers will take place, or take a seat. So the driver compartment is in this case located at the front. We need to ensure a certain level of weather protection and comfort, and we also need to have a sort of level of vehicle safety, and mostly think about ergonomics, so that the vehicle is easy to drive. And this depends on the ergonometrics of your customers. So we have the preliminary consideration to divide the available space. In this very example, we have 30, 30, and 40%. So the rear 40 and 30%, that could also be a cargo area if you want to. And then if we look at the front area, we will have the driver's seat. We will also take a look at some seat belts, the windshield, and some accessories. The process that we're going to deal with is the following. So we will look at the determination of the interior layout, then we will determine the driver position, select the manufacturer of the seat, mount the seat, select the material for the windscreen and mount that, determine some wooden profiles for the windscreen framing, manufacture the windscreen frames, we check the geometry again, and then we manufacture the windscreen, mount them or mount it, and then we talk about the entry support and the floor mats and mounting accessories. If you move on to the first step, we will determine the interior layout, and the interior layout is actually now split into two slides. So first of all, you should think about how you want to divide the surface area available. And if we look at this, we have a certain length available now here. The driver shouldn't take up too much space probably, so about 30% in this very particular case. Makes sense. Sometimes it makes sense to go by full meters and not by percentages. So we usually would recommend that something in between 700 to 1000 millimeters for this first area might make sense. And again, you will take some measurements for the second seating row and for the third seating row. It depends on the use cases you have to think about, but always bear in mind the anthropometrics, so the proportions of the people, so how high is the average person in your market area you're targeting, how tall is the upper body, how long are actually the legs, how long are the upper legs, how long are the lower legs, because that will all later on define the spacing you need to take into account here, and in the other rows. If you look at the sort of second slide here, we see that that we have these percentages, and what we also do is that we position the battery underneath the driver seats, just in case that you want some storing space over here for passengers who might carry some bags and so on. So the determination of the driver position, this is something very important. The driver position is now, let's say, the vertical positioning of the driver, and we consider that the driver sits in the center of the vehicle regarding the width of the vehicle, and the height is something you have to bear in mind. It shouldn't be higher than the maximum length of the lower leg of an average person, to make sure that you're not uncomfortable while sitting. And a sort of standard height we can recommend is 430 millimeters. In automotive terms, there is also a special measurement for that. So there are some standards from the Society of Automotive Engineers called SAE, and there are some further descriptions of different measurements in the standard of SAE J1100. And the measurement we're talking about here would then be referred in this standard as the H30, so it's the distance from the point where you place your foot on the floor of the vehicle and where your hip point is. But 430 millimeters seems to be somewhat of a good approximation. Once we've established that, we will move on to the selection manufacturing of the seat. So you can choose a seat that you find on market that you want to have that fits your ergonomic requirements. You can try to recreate a seat on your own or to manufacture one on your own. But we would, in this case, refer to taking a seat out of the market, for instance, a motorbike seat or a car seat. If you have that, the mounting of the seat has to take place. Obviously, what do you need? You need the frame and you need some wooden profiles to accommodate the battery around. So this is what we do. So we build out of wood a sort of box that we can mount the seat on. What we need for that, we need a drill, we need some tap screws and screwdrivers, and probably a hammer. As you can see in the description over here, what we do is we take into account what is the current size of the battery. Then we are building around that a box, basically a square box, which is a cuboid kind of shape, and we will then have this box set up around and placed there. So the batteries are placed inside this box, and we would also recommend to have a little bit of spacing because batteries can get warm, especially during charging, and therefore it is good to have some air and some ventilation going on. The second stage of the seat mounting will then be to cut the wooden profiles into length and to assemble them and to mount them on the metal profiles of the base frame by using a drill and using some shackles to position them. So the shackles are identical from the manufacture way, like the ones that we used for the battery. The wooden profiles depend a little bit on what you want to have. There should be something like a section of probably 40 by 40 millimeters at least, and it should be properly screwed and probably bonded adhesively as well. And the third step would then be to weld the metal profiles between the horizontal metal profiles to the support frame, as you can see in this very picture over here. And once this has been done, we will mount the seat onto the box. Usually the seats are provided with some bolts and sometimes some sliding mechanisms so that you can have a longitudinal adjustment of the seat, and this is done by drilling and then bolting the seat onto this mounting box. And this is what will also be mentioned in the last slide of this step. Now let's move on and have a look at the protection of the driver. We'd like to build up a windscreen, and the material we will use to create the frame of the windscreen is actually wood. Now, why to do so? Well, wood is very easy to form. It's also rather light, and we can very easily glue or bolt something to it. And since the vehicle shall have a rather low center of gravity, we want to have everything beyond the sort of support frame structure, so everything regarding the roof and the windscreen, to be as light as possible. So we recommend using wood profiles, and we would recommend using the same profile sections or types of profiles that you used for the box that will house the batteries and will be the mounting point for the seats. Now, 50 millimeters by 30 millimeters would be something like this, or I mentioned before, I think 30 by 30 millimeters. And take some measurements on how high the whole windscreen should be. So there should be some sufficient space between the head and the top of the windscreen for the driver. So there is a proper wind and rain protection, and there's also enough, let's say, headroom available. And once you've done this, we move on and look a little bit on the windscreen itself. There are several things that you could use that are translucent. We would prefer something like plexiglass. Is rather light, it's very easy to deal with, and is not as brittle as glass would be. So in the case of a crash, it wouldn't crack, so there is no hazard here. It would be safe, and it's actually very easy to be replaced. So this is something we would prefer. And then we would go on to determine the profiles for the windscreen. So again, take the dimensions closest to the gap, so from the support frame down here and from the roof up here, and then you know how wide your frame needs to be, and you also know which kind of length you have to get across in order to make this a sufficient protection for wind and rain and anything else that might be on the road. Now, manufacturing the windscreen holder is actually very simple. If you have your length, you will then again mark it on the wooden profiles, and you cut the wooden profiles according to the dimension of the steps that we have just specified. The tools that we're talking about are usually just tape measures, saw, pencils, wood screws, screwdrivers, drilling machines, and some tabs. And then once you've done that, these profiles will be joined together. And we recommend using 3 screws per connection point. You can use glue additionally if you want to, but it's not really necessary at this point. So once you've done that, you please place it in the space where it should be installed. And yeah, just check the geometry if everything is all right, and if it's not correct, yeah, it should be corrected. If we now have the frame for the windscreen available, we probably have to manufacture the windscreen as well. So we have our profiles from the panel support, and we do now have our our material available that we want to make the windscreen out. And similar to something we did with the base frame, we would now recommend creating a template. So what we do here is, again, we use some cardboard, for instance, and the cardboard is then used to determine the actual size of the windscreen and the way how we need to fold it. Then we transfer the dimensions from this cardboard template onto the plexiglaze, and then we take the plexiglazing and actually cut it out via a saw, and then we will have the final contour of that. Now, if we have the final contour, you can place a plexiglass pane on the intended position on the vehicle, and you can check the bending points. The bending of the material is rather easy. You can use heat, and then you can very carefully bend it around the edges of the frame. Then you have the right shape, and once you have the right shape, it's then needed to mount the windscreen, we then again would recommend screwing it onto the frame. So probably 6 bolting points should be enough. So hold the windscreen in place, drill some holes through the windscreen and through the wooden profile, and then secure the windscreen on the profile with some wood screws. If you want to, you can use some seals to seal things off, but it's not particularly necessary. Another thing that might be added to this is the so-called entry support. So it's basically just a handle that you can grab and then get into the tuk-tuk more easily. So just check a suitable point for it, where to place it, and then again mark the holes you need, drill the holes, and then screw it onto the frame where necessary. Something that is also to be considered are floor mats, or some kind of floor device, in order to prevent slipping if there is a wet weather condition. You can use any kind of fabric you would like. You could use some plastic mattresses in order to get a sufficient grip, and this is then cut into piece or cut to size with some scissors or a knife. It doesn't stop there. You can try to make the driver compartment as sort of fitted to the requirements or needs of your users as closely as possible. So there are a lot of accessories that can be bolted onto this section. Please make sure that you just check if they're in a sort of accommodated space, that they're not blocking the view, and then you can mount them very easily on there. And yeah, things to be considered might be a fan, might be an air duct, might be a phone holder for your mobile phone, might be some interior lighting, or especially some rain covers depending on the area where you're driving and using these vehicles. Just make sure at the very end that everything is securely bolted and sealed. So if there is, for instance, some rain, that you don't have some areas where rain will probably intrude in here, where you have the area where the roof and the windscreen are joining, and then you're probably good to go. So let's move on to the rear compartment, and now the example of the passenger area. Now the passenger area is something that is located obviously behind the driver, and should have a certain level of comfort, since you want to have to offer that, which is something again that would set you apart from other competitor vehicles. And the input that we have in here are again wooden and metal profiles, and also wooden and metal plates, some foam, some fabrics, and some seat belts in order to safely secure the passengers. These things are then assembled, and the output would be something that we call a seating bench. The process for that is also quite lengthy, and we will go through it again from top to bottom. So first of all, we should choose the number of seating rows that are necessary, and then we know the position of the seats on the chassis and also on the struts. Then we saw the steel seat frame profiles to length, cut them to meter, and then holes will be drilled for the profiles. The profiles will be tack welded, and they will be finally welded, and there will be some wooden profiles to be sawn into place, and we will saw some wood plates for the seat benches and the backresters to size. We will screw the wooden profiles into place, and then we start with the upholstery of the seats and the backrest, and we will mount then our additional boarding aids, or grab handles basically, for the second or third row. We will also mount the seat belts, and then finally mount the wooden parts to the steel frame. Then we will have to measure the mounting positions, drill the holes in the floor, and then mount finally the seats and the overall vehicle. So let's start with the first step, which is to choose the number of seating rows. As mentioned before, you can have as much seating rows as you'd like. We currently plan with 2 seating rows, but we're just going to show you 1. So if you want to have 2 seating rows, you need to carry out the steps 3 to 17 twice, which is just basically the analogous way, 1 for the second and 1 for the third row. So the row, as you can see here, is placed back to back, so you have a little bit more space here for the last row, and don't need to concern regarding the leg space. If we want to position a seating row, we have to make sure that we know where the chassis struts are actually positioned. So as we can see in this depiction here, the base frame has some lateral moving struts available, and they have to be placed on that in order to have a good grip, because if you place them on the actual floor plate, that would probably not be sufficient enough. So in this case, we would ask to position them on this strut and on this one, and if not so, you need to create some mounting plates, but we are going to place it on the struts that we have available. And the position of the struts shall be marked on the inside of the vehicle, so take your chassis plans, take your tape measure and a little bit of chalk, and just draw that onto the floor of the vehicle so everyone knows where these struts are actually running through. And then measure the distance between the symmetrical struts at this point, so that they are apart for the benches that you need. So the first bench, so the second seating row, will be placed on this strut, and the other row will be placed on the other strut. To create the seat, we will go through it step by step, so from bottom to top basically. So we need to have some kind of seat frame, some support frame, and this is done out of rectangular steel profiles, 60 by 30 millimeters, thickness again 3 millimeters, which is way sufficient enough. And again, you start with a tape measure, scribe, a saw and band file. You start measuring the profiles to length accordingly to the plan, and you end up probably with a sort of shape something like this. So it's a kind of U shape where you can take the seating pan, and you have also some area where you can bolt the backrest to. Then you saw the profiles to length and deburr again the profiles. And once you have done this, the profiles will probably be cut to meter, and again be deburred. And if they are done like this, we start to drill some holes for the profiles. Just position them on the areas where the struts are, so we know that we will definitely hit one of these struts later on. And once this has been done, the profiles that have been cut to length and meter will then be tack welded. Use again at least 4 tacks to secure that, and then please check again the geometry. Once you have established that the geometry is right, you go for the full welding process, and please check after that again the geometry and the welding seams if they're all right. Now, if you have that available, we will move on and work our way up into the seat area, and we will saw the wooden profiles to length that we would then need in order to build, let's say, the structure of the seating bench where you're actually sitting on. So rectangular profiles out of wood, 60 by 30 millimeters would be all right. You use a tape measure, scribe, saw and file, and you measure the profiles, take the maximum width that you can take within the vehicle. Then you will mark the profile length, and then you saw and deburr again these wooden profiles that you've cut to length. Now they build basically the subframe, and then we're talking about the areas where you sit on. This will be mounted on plates, so we need to have some wood plates or planks. At least 3mm would be recommended, depending on which kind you use. We would also recommend using at least 10 or 15mm. For instance, if you use blockboard. And then these planks have to be measured out with a tape measure and then be sawed. So measure the wood and leave room to ensure that you have some space for your seat belts later on. Mark the cutting edges on the wood planks and then saw them and deburr them as well, so you don't have any splinters going on. Maybe sanding will also be needed, so just have an eye for that. Now we do have the plates or planks, and we have our wood profiles underneath, so we need now to join these two. So we take our wood plates that have been cut to size, and we take the profiles and some screws, and we screw these things together. So the profiles will be laid into the shape that we need on the plate, and then we just screw these two things together at this point. Now this would be very uncomfortable to sit on, so there will be some upholstery needed. This is something that you can do on site. We need some upholstery material, so some foam. The denser the foam, the more comfortable it will be. We need some upholstery fabric, which is covering the foam. Probably some glue, some staplers, some scissors, and some knives. So what to do would be to take measure for the foam, then cut the foam into the right size. As you can see here, it should be a little bit above the edges of the wood planks, and then you will glue foam onto the wood plank. And once you've done that, you will cut your upholstery fabric to size, wrap it around, and then you can staple it to the wooden planks, and therefore you have your upholstery ready. Now your passengers want to get in and out, so it might be useful to have some mounting or some handles mounted. We call them boarding aid, so this would be one thing that we need, and then we need the backrest assembly. We will then need some screws and some screwdriver to place them. Again, the positioning of these things will be up to your liking. Just make sure that they're in an ergonomically useful position. Mark the holes that we need, drill some pilot holes, and then screw or bolt these handles to the backrest. The next thing that we're going to look at are the seat belts. Now the seat belts are something you can get from somewhere else on market, and what we need again are some wrenches, bolts, nuts, and also a drill. As you can see, we created this metal subframe. This is where we'll also bolt on the seat belts. So don't bolt the seat belts to the wooden parts, always bolt them to the sturdy metal parts here. And just calculate how many people you want to have here. We are currently thinking about 2 people, but probably 3 would be also right in one row. And then you position the seatbelt attachment points, drill a hole through the profile, and then with bolts, nuts, and washers, you secure them and bolt them to the profile, and the lock is done in a similar way. Once you have done that, everything should be ready, so we can mount the wooden parts onto the steel frame. So we have all our wooden assembly parts, so basically the backrest and the seating pan, this being the backrest, this being the seating pan. And what we need again is a drill, some screws and a screwdriver. It would be great to drill some pilot holes into the wood and then screw the backrest to the plate. In this case, it will be the support frame, and also down here onto the support frame of the seat. And for the seat pan, we will also place it on the support frame. So all these things should then be secured tightly, and by this stage of the process we now have our backrest and our seating pan with the seat belts mounted to the support frame. Well, the support frame is not mounted at the moment to the base frame, so this is something we still have to do. So please mark or take out the marks on the base frame where the struts are running through, and then you take the whole seat assembly and place it accordingly where you want to have it. So measure the distance of the mounting holes of the seat assembly and mark your mounting points, and the next step would then be to take a drill some holes into the strut positions, and if necessary also into the base plates. And after that the seat will be mounted. So we will have the base frame and the seat assembly, some bolts, nuts and washers, and they will be wrenched with a torque wrench to the base frame. If you want to have a little bit of adjustability, you can use longitudinal drilling holes in this structure in here. So you could slide the seating bench a little bit forward and a little bit backward. This is something you can do. And yeah, tighten it securely. Think of a reasonable amount of torque so this doesn't move in the event of, for instance, also a crash. So the quality gate would be that you can confirm that the seats are firmly secured. And as mentioned, if you want to have this for a second, or in this case, a third row, which would be behind the second row, you have to just repeat the process from step 3 till step 17. So let's move on to the next domain. So let's have a look at the domain of the rear compartment and now the cargo area. So we have two options. We can have either the person or people transport, and we can have the cargo transport. And this is now the option for the cargo area, which is again also located behind the driver compartment and is therefore to transport goods from A to B. A very important thing is that you have to think about what use case you have and which kind of payload you want to have, which might be completely different to what might occur regarding payload if you want to carry people around. So it might be that you expect or see some higher loads with this cargo use case. Again, we will have some preliminary considerations, so where are the anchoring points for our securing of the load. Then in the assembly area, okay, where do we want to have our tailgate and where do we want to have some side panels to stop things from falling out of the vehicle. The process for this looks like this. We will start with the determination of the attachment points for the securation of the load. Then we'll look at the manufacturer attachment points. Then we'll look at the layout of the tailgate, the material selection and the size. We will then weld some hinges to the frame, and then we will use to install the door to the hinges. We will check the geometry cut some sheets into space in order to have our side panels, and screw these panels to the profiles and check the geometry, and then install the closing mechanism in the very end. So let's start with the first step here, which is the determination of the attachment points. Just need a tape measure, a calculator, and a scriber at this point. Again, check out where the struts are. This would be where we can secure some stuff and provide these anchoring points. We would say that at least every 500 millimeters on the left and on the right hand side of the vehicles, you should have some anchoring points. Maybe you can go a little bit down, make every 250 millimeters if possible, so you can secure more tightly. Then we will manufacture the attachment points. The only thing is that we need some threaded eyelets, drilling machine, tap and center punch. You just drill the marked points through and insert the threaded eyelets, and then secure them with some nuts. Once this has been done, we need to look at the sides and the tailgate. We start with the tailgate first. So choose a tape measure, calculator, pencil, and scriber, and you need to determine first the height of the tailgate that you want to have, and the position of the hinges that will be on the support frame areas, or also on the base frame. So it depends on whether you want to swing it around Z-axis or around the Y-axis. If you have figured out the layout of the tailgate, the material selection will be the next thing to do. There's a wide material range you can choose from. You can use wood, you can use metal, you can use some plastics. In this case, I think we're going for some wood because it's rather cheap, rather light, and is very easy to tool. So this makes things a lot easier. But again, if you have things that need to be super resistant, maybe going for metal would make sense at this point as well. If you have figured out the sizes of the tailgate, but also the side panels, mark them down, because we will need to use them later on. The next thing would be to weld the hinges of the tailgate. So what you need the frame, and you need a couple of hinges, and we will MIG weld them again. So again, tack weld them at the determined position, in this case of the vertical support frame, right here at the very end, and then check the geometry. Once you've done that, take your measurements you've taken and transfer them to a wood plank, and if you have the wood plank, then you just saw it into the according shape. So this should be a rather easy part, and the next step is then to mount this wood panel onto the hinges. So you need your panel, and you need some screws, screwdriver, and you will mount this on the hinges. Make sure that the hinges will swing properly afterwards, and that there is no sagging down of this tailgate at one end or the other. So this is what the next step is all about, checking the geometry, whether everything works fine. So things to look at is, for instance, whether the wood panel is parallel to the floor. If not, you can correct it slightly with the hinges, or you might just need to screw new attachment points. And yeah, if anything might be incorrect, please correct it. Now we have a swinging door. We want to close that also at some point, so we have to frame or to have a catch with a tailgate. So we need a drilling machine, screws, tabs, and a MIG welding machine, and we will screw the locking mechanism and the catch, so the locking mechanism will be attached to the vertical profile, and the catch will probably be attached to the wooden plank tailgate. So let's move on to our next domain, and this would be the roof. The roof is very important because it will protect the driver and the occupants or the goods that you transport from any kind of weather influences, but it will also, to a certain degree, enhance the structural integrity of the overall vehicle. And it will also complete the vehicle exterior after all, and is one of the main components that we are still missing. The input are again some profiles. You could use metal profiles, you could use plastic profiles, or wooden profiles. Always bear in mind the lighter the better, because this is now mounted rather up high in the vehicle, and then this is assembled, and the output will be the base frame with now the roof added. So let's have a look at the process. So let's have a look at the process. We will start with the material selection, then the transfer of base frame dimensions to the roof. We will manufacture the roof and construct it with profiles. Then we will have the determination of the cabin height, the extension of vertical profiles, the fastening of the roof to the body, determination of the external paneling, manufacturing the external paneling, and if necessary, do some corrections. So let's start with the first step, which is the material selection, to use the right material for the structure of the roof and the vertical profiles, depending on the abilities that you want to have. If you want to have a vehicle that needs to be very stiff and shall actually have something like a roll cage, you should probably go for the same material as you've done for the support frames, the vertical parts. But in this very case, we are opting for something different. We will opt for wooden profiles that fit into the inside of the vertical struts, and our roof doesn't have to take any big loads, and we want to be as light as possible. So this would be the plan to go for, and this is the following stuff to come. You could also imagine to use some plastics, but let's say plastic, wood, and metal are the most common things to use here. The next point would be to transfer the base frame dimensions to the roof. So we're basically mirroring the base frame. We only need a saw and a tape measure, and we take the dimensions, the number of profiles from the base frame, and transfer them to the roof. We already have them available, and then we will lay out the wood profiles accordingly. We have cut them to length, we have cut them to meter, and then in the next step we will manufacture them. So we have our wood profiles available. We will need some wood screws and screwdrivers, and we will then screw the wooden profiles together accordingly to the dimensions we have set earlier. And as you can see, we end up with something that looks very, very close to the base frame. It's identical to it actually, and will be the top of the roof then. The next step would be to determine how high the roof needs to be in order to have a certain cabin height. Now, there is the question whether we want to stand fully upright within your electrified tuk-tuk. We opt not to do so, but to have a height that gives us enough headroom and also a good in and egress of the vehicle. So we are settling between a range of 1,200 to 1,500 millimeters measured from the base frame up to the lower part of the roof. But you can do this to personal preference or other limitations that there might be. Based on that, the vertical profiles will then be constructed. So again, we will use wood profiles, and we will use the frame that we just did. we have a drilling machine, some screws and some screwdrivers, and then we will determine the length of these vertical parts, and we should consider that approximately 200 millimeters should go inside the support frame, the vertical support frame parts, in order to have enough of an overlap. That would be what we do, and then we drill, as we can see in the next stage, through these support frames, and then we will actually secure them with wood screws so that the whole roof profile is then secured and fastened. This is what we'll do also in this step. So we will fasten the roof at the very end. So in the step before, we just fastened the vertical parts. Now we will fasten the roof overall. 3 screws per joint should probably be enough, and these screws can be set at a 45-degree angle in order to go through properly. Then we have the frame structure of the roof, but we don't have a cover, and this is something we have to determine right now, which is the determination of the external paneling. First of all, we have to select a material for the outer paneling according to either your own ideas or some requirements, and the design of the side panel is also an option that we can go through here. Now, a wooden substructure is usually the most easiest, and the following instruction shows a covering with aluminium seal or sheet or wood planking or paneling, or also fabrics. That could also be something that you might take into account. So if we manufacture the external paneling, we have the paneling material, frame, wood profiles, wood screws, and maybe some nails. We need a hammer and a drilling machine and some screwdrivers. And the process is that you create, again, the outline of the needed substructure from the wooden profile, and the paneling can be attached to that. In the next step, you would place this paneling on top of the profile, and it will be connected with some screws or with some nails. Depends on what you prefer. Make sure that if you want to have it completely weathertight, to seal off the screwing or nailing areas. And then at the last, if you use some fabric, you can use it and stretch it around the outer skins, and then just screw it or bolt it or staple it to the wooden frame. If you do so, please remember fabric is probably just more of a sun shield and not a protection against any rainy kind of things, but therefore is very light. That's one of the most important things. And yeah, that is the very last point of that process, which is, if necessary, to do some corrections, to stiffen out the structure if necessary. It could be that it is a little bit distorted, so make sure that you stiffen it out with additional screws or additional wood profiles if necessary. The next domain we're going to look at is the body structural lighting. Well, the lighting is necessary obviously for your road safety, so to see and to be seen, and also for regulatory requirements. The input here will be some headlights and indicators and some rear lights and indicators, and they will be mounted onto the vehicle. So this is what we will have as our output then. Now the process is very straightforward. We will select some headlights and indicators and brake lights, mount them, and then wire them up. So the first thing is to do that we select suitable headlights, indicators, taillights, and brake lights according to the requirements that are there. Check your current legal requirements on, for instance, the power output of these things, the number of the headlights and rear lights and brake lights and indicators, or any kind of legislation or requirements on the color of the lights. Then make the right choice from products available on stock. So let's move on. The mounting of the headlights is something where you need a tape measure, calculator, scriber, drill, and some screws, and select the suitable mounting points. Please again check the legislation requirements, because sometimes they make some notices about where they have to be installed. Now, if you've done that before, you should also fit the switches for the headlights and the indicators on the handlebar, because that is where it is the most convenient and ergonomic to place. And the brake lights are controlled by a switch on the brake lever, so make sure to position it on the brake lever, and then you can proceed with the next step. At this point, you will then just check that the lights do all work. They do have a sufficient amount of light to be emitted, and just check that they will point in the right direction and the right angles, not to dazzle some oncoming vehicles. The last thing is then the wiring up. So make yourself a suitable plan for routing of the cables. Make sure they are protected from environmental impacts and influences, and try to have a routing that is very easy to trace down afterwards, just in case if you need to repair certain things there. Last but not least, you have to solder the cables or use connectors to connect all the lights and the power sources and the signaling devices. And therefore, the last thing is the quality gate. So check all the cables, check that they're tightened up, and check the lighting equipment that it works properly and that it is pointing in the right direction and can be operated without any problem. Now we are at the domain of the final assembly, and we have several inputs here to finalize the vehicle. We will take all the assemblies from before and put them together, but we will also add speedometer. We will add obviously the brakes and the brake lines, and we will also talk about the electrical wiring and then general accessories, for instance mirrors. The process for the speedometer is straightforward. It is the adjustment and connection of the speedometer that is coming up. So which components do we need? We do need the speedometer, including its clamp, and a cable from the drivetrain unit. The tools necessary are screwdrivers, wrenches, screws, bolts, and nuts. And what we do is we adjust the speedometer in the middle of the handlebar, and then we tighten it with the clamp and the bolts, and identify the cable from the drivetrain unit in order to run it down to the actual drivetrain. We connect the cable from the drivetrain unit with the speedometer and secure the cable with a suitable cable management system. And then maybe we have to calibrate it, so that would be the quality gate. Check that the speedometer is firmly attached and works out by just checking if it's working when the engine is actually revving. We're again in the domain of the assembly and are now heading towards the brakes and the brake lines. The process is that we will attach the front brakes and the front brake calipers, and attach the rear brakes and the rear brake calipers and the lever for both brakes. So what do we need for the front brake? We will need the front brake itself, and we need the base frame and the wheel as well. Tools would be screwdriver, wrench belts, screw nuts, screws, and opener and spanners, but also brake fluid and some container for extensional or waste brake fluid. So first of all, we attach the front brake caliper to the designated position on the fork. Then the next step would be to attach the brake lever to the handlebar and make sure it's in a suitable position and a position that can be reached very easily. And the forces that are needed are very easy to apply when you're sitting in the driver's seat. And then secure the brake lines and cable with cables and straps to prevent them from slipping away. What is also now necessary is that we should pay attention to potential collisions. And the collision could be with the suspension fork because of the travel. And there it could be that there is a displacement of the brake lines. Also make sure to bleed the front brake system at this point, so there are no air bubbles in there and that the system is fully bleeded, and therefore brake force can be applied. And check in a quality gate again to see if the front brake is working properly. Now let's move on to the rear brakes. So we need the base frame with all the attached parts from before, and we need the rear brakes at this point, our screwdriver cables, and basically everything else from the front brake part. So install the brake lines from the rear axles to the front, and secure the brake lines with a suitable cable management system in sort of regular intervals. The next step would be to make sure that the brake line is routed as protected as possible, so that there are no stones that they could hit it or anything that comes up from the road that might penetrate the brake lines. And last but not least, mount the brake of the rear brakes, also the lever of the rear brakes, also on the handlebar. Make sure that it is reachable in a quite easy manner and that you can apply the force necessary. And as mentioned before, if you're using a hydraulic brake system, make sure you bleed the system properly, that the brakes are functioning properly. If you have a cable operated system, make sure the cables have the right tension to it and operate properly. So the quality gate would be check if the brakes are bled properly, and if they work fine, please make sure that you have trained personnel that really knows what they're doing when dealing with brakes, because they are the most important safety feature on this vehicle, and that they set up the brakes in such a way that they are working totally fine. So let's move on to the electrical wiring domain, and yeah, the process is also quite straightforward here. We will look at the wiring of the drivetrain control unit and the determining of the installation locations for components, and then we connect all the cables for the power supply of the motor. So we wire the whole vehicle up now. The first step would be to wire the drivetrain cables. So we need the suitable cables for the drivetrain battery connection, and suitable cables for the drivetrain control signals. What we need are screwdrivers and cable ties and routings. So the wiring of the drivetrain control unit according to the manufacturer's information should be done. And please bundle the relevant cabling for the driver compartment into one big tree of cables. Then the ignition key, gear shaft forward, and stuff like this, staff extension which is on the handlebar, needs to be routed. And once this has been done, bundle all the relevant cable for the power supply and extend the routing if necessary to the battery, and secure all the cables with the cable management system. Make sure that the cables are routed and protected as best as possible from any stone chips or anything else that comes up from the road, and make sure that they are all electrically isolated. So next we will install all the driving relevant components like ignition key, gear shift, forward and reverse sensors. So we need some screwdrivers, wrenches, bolts and tape measure. We would start off with a determination of the location of the installation parts, and if you have them, please make sure that they are also ergonomically aligned. So the next step then would be to route the corresponding cables for the relevant components to the locations where you have installed your components. Make sure that you secure the cables with a suitable cable management system and connect all the cables with the corresponding components, so to wire them up. Therefore, you attach the component to the corresponding installation location. And the next thing that we'll do is we will connect the cables. So what do we need? We need the battery charger, and the cables for the power supply. Remember, always be careful when working with high voltage components, so you need to have some trained staff here. Identify the cables for the input and output of the power supply for charging and for the motor, and then connect the cables for the power supply of the motor and the battery, so that's the output side of it, and do connect all the cables for the battery charging and the battery, so this would be the input. Now, the last part of the assembly, the general accessories. The process is very simple. Since we can't describe everything here, it's just the mounting side for mirrors, but it would be anything else that you want to mount. The mirrors are just an example at this point. So in some countries, the mirrors might be compulsory. In some, it might just be something additional you want to have. So in this case, it's the side mirror. What you need is a screwdriver, wrench, drill, some bolts, some screw nuts, washers, and a tape measure. You probably select one rear view mirror from stock, and probably want to have one on the left side and another one on the right hand side. Maybe want to have some in the middle. And just make sure you position them right, so from the driver perspective you can actually see everything. Then position them as shown in this picture, and then make sure that you figure out the holes, drill the holes, and then attach the mirror to the frame. And you can do so with all the other accessories. We've had lots of things that we mentioned before, like fans, climate controls things, some sun visors, for instance. So there is quite a lot that could be attached additionally. And in this case, with side mirrors, please check if the side mirrors are firmly secured and in place, and that you can actually see them and adjust them so that they give you the right field of view from a driver perspective. So we come to the point of final check of the vehicle concept. The final check of the vehicle concept is something you always have to do before you get the vehicle out on the road. We've just mentioned some points that you should think about. It's not a complete list, so please look into further details for that. But what you should do first of all is a general inspection. Look if everything that you wanted to do is done. Look if all the parts that you needed are actually mounted, and the vehicle fits to the dimensions and the performance figures that you were calculating beforehand. Take a look at the frame and the structure. Look if this is all well done, if it's up to your quality standards, if there are any welds from the welding that are probably not perfect. Then it's the time to correct this. check the suspension and check the wheels. So check whether the suspension travel is sufficient enough. Load the vehicle fully to see whether the travel is all right, whether the tires are coping, and yeah, just do a general check on the suspension and wheels. And you can do a little test drive and actually do a little bit of adjustment if necessary with the spring and the damper rates. Check the drivetrain if it's working properly, if it has enough power, if it's going forwards, and if it goes backwards. And then also check the energy storage. Is the battery charging properly? Is it giving the full power you actually need? Check the electrical wiring and lighting. Go through it one by one and check if everything is fine. Check the brake system. So we mentioned that during the brake part, that is the most crucial safety feature. So please make sure that you brake the car or brake the vehicle test-wise also under full load to see if the brakes withstand the full force. Check also the steering, if that's fine, or if there is some kind of wobble. Check all the controls, if they are working perfectly. Check the seats, if they are mounted properly, if you can sit well. And check the seat belts. Are the seat belts well secured to the vehicle structure? And once you've done that, do your final inspection test. Always do a test drive, and then you have to do your legislative documentation process that you need to go through, and then you can actually release the vehicle. Summary. Now, what have we seen within the last minutes? It's been quite a lot, but to put it in a nutshell, there are three things. We've seen a guide for developing a very simple electric micro vehicle. It was an example, and obviously you have to do some stuff to yourself to actually use our principles, basics, and methods that we just shown in order to create your own vehicle. But we talked about design guidelines, so we talked about the material selection, the effect that materials will have on the vehicle. We talked about mechanical considerations and production considerations, and they all made up the vehicle concept. So by now you should understand what a vehicle concept, or what it takes to come up with a vehicle concept. And we've learned a lot about requirements, which are probably the key factor to manage them in order to get a proper vehicle concept for the business case or for the use case that you're aiming to build a vehicle. And then we also did have a look at the domains of the vehicle. So we split the vehicle into several domains by the method of grouping the things. And we gave you very detailed instructions step by step how to implement an exemplary three-wheel vehicle, in this case our electrified tuk-tuk. So thank you very much for watching. I hope you enjoyed this course and you learned a little bit on vehicle concepts and on chassis and how to implement all that. And yeah, enjoy the lectures. Take care and goodbye.